So today we are going to be working with adding fractions, and we'll be using two different sets of manipulatives to work the problem. We do have a word problem here. It states Bob the baker needs 1/4 cup of sugar for cookies and 2/3 cup of sugar for a cake he is baking. What is the total amount of sugar he needs? So I have the problem wrote out here, 1/4 plus 2/3. And we know that a fraction is part of a whole. The numerator on top is the amount of parts that we actually have. The denominator on the bottom is how many parts the whole is divided into. And so in order to work this problem, we need to find the common denominator or the common multiple. So we know that 3 does not go into 4 equally. The next multiple of 4 would be 8, and 3 still does not go into 8 equally. The next multiple of 4 is 12, and we know that 3 goes into 12 equally 4 times. So we need to keep 12 in mind as our common multiple. So before we get started, let's go over a few different misconceptions students may have, especially with the early grades. Students may think that 1/4 is larger than 2/3 just because the denominator 4 is larger than 3. As you can see, this is not the case. The next misconception may be reading the problem left to right, or working it out left to right, just like we would read left to right. So for instance, 1 plus 2 and then 4 plus 3 to get the answer. The answer would be incorrect if we worked it out that way. So let's go ahead and get started with our first model. And for the first model, we're going to be using fraction squares, which work very similar to fraction circles. And so for this model, we're going to be focusing on area. Now the area of the red square is our whole. But for the first fraction in our problem, we're looking at 1/4. So as you can see here, the yellow is broken up into fourths. So we have 1/4 to represent our first fraction. And then we need to represent 2/3. The orange is broken up into thirds. So we have our thirds here. And we need 2 to represent 2/3. So we're going to add that to our 1/4. And we know that we cannot add unlike items. So we said again our common multiple of the two numbers was 12, and the black is, we have 12 black rectangles here, and when placed together they do equal one whole, or the same size as the red whole. We're going to take these 12 and we're going to see how many it takes to represent the 1/4, or to equal the 1/4. And 3 of them equal 1/4. So 3 12s equal 1/4. We'll do the same for the 2/3. So I'll just place them along the 2/3. And it looks like 8 12s equal 2/3. So together, the 3 12s plus 8 12s equals 11 12s. So to solve our problem, 1/4 plus 2/3 equal 11 12. Now that was again our area model. We're going to move on to our linear model. And for that, we're going to be using fraction cubes. Now fraction cubes work very similar to fraction tiles. We have our whole here, which is our 1 whole, red. And we're first going to look at 1/4. And so we see here that the yellow is broken up into fourths, and we only need one of them to represent 1/4. Our next fraction here is 2/3, and the orange here is broken up into thirds, and we need two of those. So we'll connect them to the 1/4. Now keep in mind that we're focusing on the length here, so we want to make sure that they're connected and aligned precisely. So we said that our common multiple is 12, so we'll take our 12s and we'll see how many it takes to equal 1/4. And exactly 3 12s equal 1/4. We'll do the same for the 2/3. So let's see here. Not quite. So again, snap them together precisely because we're focusing on length. And I can see here the 3 12s equal 1/4, and then 8 12s equal 2/3. So together, 11 12s equal 1/4 plus 2/3. Those two models, that was two ways to represent the addition problem, working with fractions. So you have learned now two different ways to solve a addition fraction problem.